So we've done this kind of problem before. We're just substituting in, and we're going to use our calculator to do that. So here we're going to store 64 to A, and we're going to store -5 into B. So let's clear our calculator. And we're going to do 64, remember, store. There's a glare there. 64 store, and we're going to use A. So we're going to do alpha A, which is right here, enter. And then we're going to do -5 store, and that's going to be in B, alpha B. Now we're going to put this in how we see it. So you got to be very, very careful in your calculator because this radical ends right here. So I'm going to put in -2, -2, and I'm going to put in the cubed root. So I'm going to do math. So when I go to math, you see right here, that's the cubed root. So I'm going to pick the cubed root. I'm going to go down. I'm going to put an enter. And now I'm going to put an A. So I'm going to do alpha A. And now look how that is. See that arrow? I have to go outside. So you see how now I'm outside that cubed root sign. Then I'm going to do plus B, alpha B, and that's squared. So I'll push the square button, and I'm going to get an answer, and my answer is 17, and there I go on my way. So you have to be careful with this right here. And we get, this is called a cube root. Think of that as one word. And to get that, you go to math, and then you go down to number 4, which has this symbol in it. Let's see what's on the next page. So this is a little tricky. It's tricky because we have a variable, so we can't do it the way I showed you before when we looked at the square root of 18, but we can probably eliminate some choices. So let's do this. Let's look at this as the number part, and let's look at this as the letter part. Okay? So let's try the square root of 42. So we're going to go into our y equals, and I'm going to do 42 divided by x squared. Okay, because I'm looking for all the perfect squares that are factors of 42. Then I'm going to go to second table. So remember, I'm going to look for my smallest y value over here. Ooh, okay. So that looks like there are no factors. See how I get 42 and then I get, okay, so that would be 1 times the square root of 42, which is the square root of 42. And I scroll down and it just gets smaller and smaller and smaller. My y gets smaller and smaller and smaller. So I know that I can eliminate this one and I can eliminate this one. Okay, so those are not possibilities. So that means it either has to be this one or this one. So now I have to look at this. Well, what does this mean? When I have a square root, it means I'm looking for multiples of 2. That's understood to be there. So let's look at this. So this is the same as n squared times n squared. So this is, we're going to add these. So that's 2 plus 2 is 4, plus 3 is 6, plus 2 more is 8. So to get 9, I have to have one more, right? So this says I'm looking for, here's one that comes out as an n. Here's another that comes out as an n, so it's coming outside of the radical. That's another that comes out as n. Here's another that comes out as n. And then I'm left with one inside. That one doesn't get to come out because he doesn't have a buddy. So how many am I multiplying together? 1, 2, 3, 4. So that's n to the 4th. Remember, this is still under the radical. So I have the square root of 42 times n, because this is under the radical. So it has to be, I'm sorry, it has to be this one. The other way you could have done it, if that's a little confusing, if I'm looking at the square root of n to the 9th, I can think this is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm looking for pairs. There's a pair, there's a pair, there's a pair, there's a pair. Each pair, I have an n. How many pairs do I have? I have 4. Do I have any that's not paired up? Yes, I still have an n underneath. So that's the other way that you could look at that. Okay, so looking at systems of equations. So systems of equations, we are looking for, that keyword right there means we're looking for the intersection. Okay, so notice this is already y equals, so we're going to put this in y1, but I can't yet put this one in y2. So that means I have to do math. Sometimes you have to do a little bit of math to use the calculator. So I want this to be y equals, which means I want to leave y where it is, leave it there. So what's happening to the y? Well, I have a 7x being added, and I have a 4 being multiplied. So I'm undoing. So what's easier to undo? It's easier to undo an addition or a subtraction before a multiplication or division. So I want this to go away. Go away when I'm adding means it's going to turn into a 0. So what makes 7x turn into a 0? A negative 7x. Be careful, be mindful of that equal sign. I have the negative 7x on the left. I'm going to put a negative 7x on the right. I intentionally did not put it underneath that bugger because they don't get added together. So this by design became a 0. Then I have 4y equals, just by convention, I like putting my x terms first, negative 7x minus 1. I don't want 4y, I want 1y. 4 times y, so I have to untimes. So to untimes, I'm going to divide. So I'm going to divide everything by 4. That's what's tricky on that. So that means y is equal to negative 7/4 x minus 1/4. Okay, so remember, I'm going to put that in y2. So that goes in y2. And this is my y1. So like I said, sometimes you have to do the math in order to let the calculator help you out. So I'm going to put in negative x plus 2 in y1, and then in y2, you can use a fraction thing if you want, or you can do parentheses. I'm going to use parentheses for right now. Negative 7 divided by 4, that's my fraction, times x minus, and I can do this too, 1 divided by 4. Okay, so I'm going to graph them, and remember, I'm looking for the intersection. So we've done something similar to this before. So I can see I have an intersection right here. Do you remember where to go to get that? You're going to go to second, trace. So let's do that. Second, trace, and number 5. Number 5 says intersect. I can just push number 5. My cursor is on the first curve, which is the blue one. It's close, so I can push enter. That's on the red curve, second curve, so I push enter. I never guess, I only push enter. Notice it says the word intersection. If it doesn't say the word intersection, you didn't get it. So here my x is negative 3, and y is 5. I wrote them both down. This is the point negative 3, comma 5. Okay? So what am I saying? I'm looking at my intersection. That's where my solution is. and it's that point right there. So what are they looking for? You got to be careful. They're looking for the value of x. My value of x is -3. Notice they also give you a value of y. They're trying to trick you, so you have to slow down. You have to be very careful. So that's my solution there.